In this demo, we'll work with the Vertex AI APIs on the Google Cloud using Vertex AI Studio. Vertex AI Studio is a Google Cloud console tool for rapidly prototyping and testing generative AI models. So you can use the visual interface of the studio without writing any code and test sample prompts, design your own prompts, and customize foundation models to handle tasks that meet your application's needs. In order to do the demos in this learning path, you need a Google Cloud account. I'm going to log into my Google Cloud account at console.cloud.google.com. Make sure your enterprise account or your Gmail account has access to the Google Cloud console and go ahead and log in. On the Google Cloud, all of the resources that you provision have to live within a project. And here you can see that I have pre-created a project called GCP-LLMs. Select that project. You can see this is the project that we'll be working with. I have many projects that this account has access to, but GCP LLMs is the project within which we'll do all of our demos. We have our Google Cloud project selected. The project is a container within which we'll provision all our resources. Let's head over to the dashboard of this project, and this gives you a big picture overview of everything that's going on in your project, all of the APIs that you've hit, a quick look at your billing and other details. If you look at the card off to the right, you can see that I have billing enabled for this project. In this learning path, we'll work with Vertex AI APIs and the Gemini models that Google has to offer, and this will of course cost us some money, and that's why you need to have billing enabled of your project in order to use these APIs. Up on the top left, you can see the project information. The project name is GCP LLMs. The project ID, which has to be globally unique, is the same. That's GCP LLMs as well. And the project number that you see here is a unique numeric identifier for your project that Google assigns when you first create your project. In order to view all of the products that Google has to offer, you can click on these three horizontal lines, the hamburger icon, and this will bring up a little dialog within which you can click on View All Products. This will take you to a page that will show you all of the products available on the Google Cloud. If you scroll down, you'll find that the different products are categorized based on networking, distributed cloud, serverless, compute, storage, and so on. Now, the section that we are looking for is artificial intelligence, and within that, I'm going to click through to Vertex AI. This is the unified AI platforms for ML and AI solutions on the Google Cloud. And this is where we'll work with large language generative AI models. Here on this page, you get quick access to a number of different products and features on Vertex AI. What we're going to work with first is Vertex AI Studio. The Vertex AI Studio is a playground where you can work with different APIs that Google Cloud has to offer without writing any code. This way you can play around with these APIs, figure out which one works well for you, and then of course use those APIs within your product. There are of course a whole host of other solutions here, but because we are focused on large language models, we'll work with those APIs that allow us to access these LLMs. Now on the left under Vertex AI Studio, click on Overview. Now if you're working on a brand new project and you're using Vertex AI for the very first time, you should see a pop-up that looks like this. In order to work with Vertex AI, there are two APIs that you need to enable on your Google Cloud project. There is the Vertex AI API and there is the Cloud Storage API. You can see from this dialog that the Cloud Storage API is enabled. In fact, it's enabled by default for all new projects that you create. However, the Vertex AI API is not enabled. If you click on Agree and Continue here, Google Cloud will automatically enable these APIs for your use. So that's what I'm going to do here, and let me show you that these APIs are now enabled. Head over to the navigation menu, go to View All Products, and here at the very top you can see APIs and services. This will take you to a page where you can view what APIs are actually enabled. Now here if you scroll down to the bottom, you can see a list of all of the enabled APIs. And here you can observe that the Cloud Storage API as well as Vertex AI API are both in the list of enabled APIs. Let's confirm this. Click on Enable APIs and Services, and this will take you to a page where you can search for specific APIs to enable. I'm first going to search for the Cloud Storage API, and here you can see this is the first result here. Let's click through to this API and observe that this API is enabled. There's a big blue Manage button that allows you to manage this API, but the API itself is enabled. Click on the back button of your browser to go back to the search page, and search for the Vertex AI API. Again, you can see the very first result here in this list. Click through to the API and you can see that this API is enabled as well. You're now all set up to use Vertex AI Studio. Now that we have the APIs enabled, let's head over to Vertex AI Studio. I go to View All Products, and in the Artificial Intelligence section, I should be able to find Vertex AI. And because this is the service that we're going to be using in this learning path, I'm going to go ahead and pin this to the navigation menu. So this will give me quick access to Vertex AI right from the navigation menu itself. With that done, let's click through to Vertex AI and let's head over to the Vertex AI Studio. Once again, using the left sidebar, head over to Vertex AI Studio and click on Overview. The Overview page will give you an overview of all of the different features that you can test out using Vertex AI Studio. You can have free-form generation, chat generation, translate text, generate images, convert or synthesize speech. If you scroll down below, you'll find a number of samples from Google's prompt gallery. These samples will give you an idea of how you can configure Google's Gemini model and other models to work for different use cases. The first thing we're going to try out is free-form mode. The free-form mode is used when you want to ask LLMs questions where you want the LLM to perform a certain task, such as summarization or classification or extraction. This does not have any conversation history, so there is no chatbot-like interaction where you follow up on a previous question with more questions and the chatbot keeps track of the previous questions that you've asked and you've received responses to. The freeform mode is different from the chat mode. The chat mode is used for chatbot tasks where there is a conversation history that the model has access to and the model keeps track of that context, that conversation history in order to give you your responses. So we'll try freeform mode first and then we'll move on and look at chat mode. Go ahead and click on Open Freeform. This will take you to a user interface where you can specify your prompts and get responses from the model. Let's just orient ourselves with this user interface. Observe at the very top, you can specify system instructions to the model, which the model will then use to produce your responses. In the center, we have the prompt input. This is where you will write your prompts. You can, of course, insert media into prompts. You can add examples, add variables. We'll look at all of that. You'll get responses to your prompts at the very bottom in the response section. And off to the right, there are a multitude of parameters that you can use to configure and tune and tweak the responses from your model. We'll be working with all of these in due course. The first thing to note is you can send your prompts to the different large language models that Google allows you access to. If you click on this model dropdown, you can see all of the different models that are available and what they specialize in. At the time of this recording, the latest model is the Gemini 2.0 Flash experimental model. It is a multimodal model, that is, it has been natively trained on multiple modes of input, meaning it has been trained on text, images, videos, and audios all together. You can see that the first two models have been tagged as experimental models. The Gemini 1.5 Flash 002 model is the first production grade model that we see here on this list. You can scroll down this list and here you see that Google offers access to many third-party models as well, such as Anthropic's Claude model and Meta's Llama models and different variants of the Anthropic and Meta models. At the very bottom, we have specialized models, the Palm 2 model for security tasks and the Cody model for code generation tasks. Let's stick with the Gemini 2.0 Flash experimental model, their latest, most powerful model, and let's try out our very first prompt. I'm going to leave all of the other settings to their default values. Here is my simple prompt here. I'm planning a trip to Europe and would like some recommendations on what cities to visit. Can you help me? I go ahead and click on the arrow button to submit the prompt, and here you can see the response from the Gemini model. The response is very detailed and asks you a bunch of follow-up questions as well. Responses from these LLMs use Markdown, so you can quickly highlight the important parts of the response. You can simply deselect this and you'll see the raw response from the model. This is the raw response in the Markdown format. Markdown, if you're not familiar with it, is a lightweight markup language that uses plain text formatting to create structured documents like web pages, documentation, and README files. Let's ask this same question, the same prompt of a slightly older model. So instead of the Gemini 2.0 model, I'm going to scroll down and use the Gemini 1.0 Pro 001 model. This model is still fairly cutting edge, but you'll find that its responses are not as detailed and rich as the Gemini 2.0's responses. So I'm going to go ahead and submit the same prompt to the Gemini 1.0 model. And here is the response. Here you can see that the response is far less detailed. It doesn't ask you follow-up questions and just gives you a bunch of options or recommendations for Europe. The great thing about using LLMs on the Google Cloud is that not only do you have access to Google's models, but several cutting edge models from third parties as well. Here, I'm going to select the Meta Llama 3 70 billion instruct model. This is a large language model developed by Meta. It has 70 billion parameters, that's why you see the 70B, and it's fine tuned for instruction following tasks. You can see that little note there that says optimize for multilingual dialogue tasks. Now go ahead and select that model, and if you're using this model for the very first time, you'll need to explicitly enable that model's API. This model is listed on Google's Model Garden, which is just a collection of pre-trained machine learning models, tools, and resources available within the Vertex AI ecosystem. Here is the Meta Llama model whose API you need to enable before you can use that model. So click on the Enable button, and once the API has been enabled, this will give you access to Meta's models on the Google Cloud. Let's go back to Vertex AI Studio, close this. We have enabled the API, so we should be able to use this model. And I'm going to submit the same prompt to the Meta Llama model and see what its response looks like. You can see the response is fairly detailed, but I think Gemini 2.0's response was the best by far. I do like Meta's brevity though in its responses. At this point, we've successfully enabled the Vertex AI API on your project and have played around with different models for free-form generation. Let's set our model back to Gemini 2.0 Flash before we move on to the next video. I'm going to clear the prompt as well using the Clear Prompt button here. And we are now all set to move on to the next demo. In the previous video, we saw that Vertex AI Studio allows us to experiment and play around with different models right here within this user interface. But what if you want to head-on compare the responses between these different models before you pick the right one for your use case? Vertex AI makes this very easy. You can click on this compare button that you see here on top and compare different models and their responses. I clicked on compare and you can see that I'm set up with one model here, the Gemini 2.0 Flash experimental model. And you can see that it has been set up with some default model parameters, temperature equal to 1 and token limit 8192. We'll discuss these parameters and how they affect the model's response a little later on. Now we'll just focus on comparing the responses from different models. So here's my prompt. Could you please recommend some books for me to read? This is my first prompt to the latest Gemini model at the time of this recording. I'm going to add in a new prompt to a new model and compare it with Gemini's response. I click on compare new prompt, and here I can choose to specify a different prompt, but I'm going to set the same prompt as before. Can you please recommend some books to read? I'm going to have this prompt be sent to a different model. So I'm going to head over to an older Gemini model, the Gemini 1.0 Pro 002. I won't change any of the other parameters. Temperature is still 1, and notice that the output token limit, the default token limit for this model is 2048. Now, what is this token limit? The token limit controls the length of the response that you get from the model. A smaller token limit will result in shorter responses. There is more nuance to this, but we'll get to that in a later demo. But for now, you can see the default parameters are temperature is the same 1, and the output token limit is the default 2048 for this model. Nothing else to change here. I'm going to go ahead and apply this, and this will add a new prompt to this view. Applying a new prompt gave us a response from the model as well. I'm going to ignore that response for now and click on compare new prompt yet again to make a request to a different model and compare that as well. So I'll be able to compare 3 models side by side. This opens up the prompt dialog and I specify the same prompt. Could you please recommend some books to read? And the model that I'm going to select is one of the Meta models, the Meta Llama 3 405 billion instruct. This is a much larger and more powerful Meta model with 405 billion parameters. Go ahead and select the model and you can see the default values that I've chosen for the temperature and the output token limit. The output token limit is 512. That's the default for this model and we'll stick with the default. The default value for temperature for this model is 0.5 and we'll stick with that. Again, we'll discuss temperature in a lot more detail in a bit. The temperature parameter controls the creativity of the model's response. A lower value of temperature makes the model's response more deterministic. A higher value of temperature makes the model's response more diverse and creative. The fact that the output token limit is 512 tells us that we'll get briefer responses from this Meta model. Go ahead and hit apply. The prompt will be sent to this model and you can see the response here. Now, if you want to compare all three models head on, you can click on submit prompts. This will resend the prompts to all three models, get the responses, and you can compare the responses side by side here in this view. Let's take a look at the response from the Gemini model. You can see it's very, very detailed. Next, let's take a look at the response from the slightly older Gemini model, Gemini 1.0. And you can see because it's lower token length, the response is more brief. It's shorter, but it's still fairly detailed. Meta's Llama model has a token limit of 512, and you can see that its response is fairly brief. Still quite good though. If you're evaluating different models to integrate within your product, using the compare prompts option within Vertex AI Studio allows you to evaluate multiple models at the same time, take a look at the responses, and figure out what works well for your use case. You can modulate the response of a large language model by specifying system instructions. So let's go back to our main Vertex AI Studio page for free-form prompts. Observe at the top, we have an input for system instructions. System instructions are directives provided to guide a model's behavior or define its role in responding to a user's prompt. These instructions are used to set the context, the tone, or specific guidelines that the model should follow during the interaction. I'm using the Gemini 2.0 experimental model. You can see this on the top right. Now, let's say I did not specify any system instructions. Then each time you specify a prompt, you may have to give the model the context for your prompt. Let's say you're a developer working on a Django application. Each time you ask a question, you might have to say something like, I'm working on a Django app. How do I create a new URL path at which a web page is rendered? Now, the prompt itself is not important, but notice that I have to specify this context. Otherwise, the answer may not be about Django at all. Once I specify this context in the prompt, if you look at the model's response, it gives me detailed steps of how I can set up a new URL path in Django. Now, what these steps are, we don't really need to worry about those. It's very technical. But the main thing here to note is that you have to specify the context. Let's say you're going to ask multiple questions about this Django application. You can specify this as a part of the system instructions. Here in my system instructions, I have indicated that I'm working on a Django application and please respond to all queries in this context. I've used the system instruction to set the context for all prompts. And now when I ask a question, I do not have to specify the context over and over again. How do I create a custom model field and when would I need to use one? Well, I've said nothing about Django in the prompt itself, but the context in the system instructions allows the model to respond with the right details in Django. Let's say you're integrating this LLM in your product and you want the chat conversation to be in a certain voice. You can use the system instruction to set the voice of your model's response as well. Here in my system instructions, I've indicated that the model should explain coding concepts as though it's a pirate, in the voice of a pirate, teaching his crew how to conquer the digital seas. Now, let's go ahead and ask a question. Can you please help me write code in Python to check whether a number is prime? When I run this, notice the response, ahoy there, matey. And if you read the rest of the response, it's definitely in a pirate's voice. May not be very useful to have a pirate teaching you coding, but this is a way you can set the voice for your model's response. Let's say you're integrating a Gemini model in your product and it can have different kinds of responses. So here I've made the system instructions more complex. For questions on Python, explain with the energy of a personal trainer at the gym, cheering the user on with exaggerated encouragement and workout analogies. But for questions on Java, I've asked the model to respond like an endearing but slightly confused grandparent, trying to explain modern technology with outdated references. The model will now have a different voice for Python and Java. How do I check for a valid password in Python? Let's run this, and you can see the gym instructor is at work here. All right, champ, let's get those password muscles flexed. And you can look at everything else here. It's clearly a gym instructor's voice. But instead, if I were to ask for how do I check for a valid password in Java, the voice of the model will be different. Now, here you can see the model responds as a grandpa. Listen here, sweetie, let's get this password thing figured out. You can see the outdated references. We just used our dog's name and called it a day, but now you have all of these additional checks that you have to make. You can see that the system instructions have been followed perfectly. Let's look at some other features that we have in this free form mode. You can see that the Vertex AI Studio user interface gives us the option to insert other kinds of media. If you click on this little help icon here, you can see that it can work with images, video, document, and even audio files. So let's try this feature out. I'm going to upload an image and ask questions of that image of the Gemini 2.0 model. So click on Insert Media and I'm going to select an image from my local machine. Since it's a small image, 7 MB and under, I can simply pick the image here. You can see a preview of this image here. There is some kind of activity, there's some kind of a game, and there are players standing around. By the way, this is an image that I downloaded from pexels.com, which makes all kinds of images freely available for commercial use. I'm going to select this image, and having uploaded this, here is my prompt. Can you tell me what's going on in this photo? This is an image understanding question. I'm expecting Gemini to look at this image, understand what's going on, and then answer my question based on the image. If you remember when we first looked at the Gemini 2.0 model, I'd mentioned the fact this was multimodal, meaning it was natively trained on images, audio, video, documents, and text. And when you send this prompt to the model, you'll see that it responds beautifully. It has understood what the image is about. A group of people playing a sport, likely some form of outdoor game. It talks about their clothing, the action. It talks about the different individuals in the image and the setting, the background. You can see that Gemini's image understanding feature is pretty phenomenal. Let's try this once again. This time I'm going to upload a different kind of image. Again, I upload the image because it's fairly small, and I'm going to upload this image of some food. As you can see, this is some kind of a sandwich, and this sandwich looks like it would make a very delicious and filling meal. But I'm curious about something else. I'm curious about the calorie content of this food. And that's what I ask in my prompt. Can you estimate the calorie content of this meal? Let's see what Gemini has to say. You can see it first describes the food, some kind of open face sandwich or toast with toppings. It breaks down the components visible. I really like that. Bread, toast, toppings, and some kind of sauce. And for every component that's visible, there is a calorie estimate. And then it tells you that totally it thinks it's about 280 calories. Let's say you're working in an organization that's building some kind of weight management, health management app. This could be a cool bit of functionality that you could integrate using Gemini APIs. Upload a photo of food and get an estimate of the calorie content of that food. It's not just about food and activity. Gemini models can help you interpret charts as well. I have an image here of a scatter plot, scatter.png, and I'm going to go ahead and upload this. You can see the scatter plot here shows the relationship between two variables, and the relationship is fairly linear. Let's see if Gemini can help interpret this relationship for us. What is the relationship between the two variables? Let's send this to our model, and here you can see that there is a positive correlation between the two variables. It also explains why there is a positive correlation. It then talks about the strength of the relationship, that's moderately strong, and additional observations as well. So it's a pretty good summary of what's going on in that scatter plot. We can work with other kinds of media as well, documents, audio files. We'll see that by and by. Let's move on and see how we can work with variables in Gemini. Variables allow you to customize the prompt that you send the model. Now, notice my prompt here. Please recommend a book in the genre for me to read. I haven't really specified what genre. I'm going to configure that as a variable. Click on Add Variable, and this brings up a dialog where you can configure the variable name and the value for that variable. You can see that the variable will act as a placeholder for the variable value, and it's the variable's value that will become a part of the prompt when we submit the prompt. So let me specify a variable named genre, that's the genre of book that I'm interested in reading, and I'm going to set the variable value to fantasy. When I click on apply, this variable is inserted where my cursor was positioned. You can see the name of the variable in curly braces, and the current value of the variable is fantasy. So when I submit this prompt, I'll get recommendations for books in the fantasy genre, and you can see that in the response. All of these are fantasy books. Now, I'm still interested in books to read, but maybe I'm not really interested in fantasy. I'll now click on this variable and change the value associated with this variable. So instead of fantasy, I'm looking for detective books. So in the detective genre. So now when I submit this prompt, the genre will be detective. And if you look at the response, you can see that Gemini recommends detective books for me. There are recommendations for Agatha Christie, G.K. Chesterton, Tana French, and so on. In a free-form conversation with a Gemini model, you can also configure examples. Examples allow you to specify what you'll pass in as a part of the prompt and what the response should look like. Examples help the model understand what you're looking for in the response. So you'll specify an example here, and the model's output will be based on your example. So notice here in the input, I say review, that is the input that I'm going to pass into the model. And in the response, I want the sentiment of that review. This is an example of simple classification. Go ahead and add examples. On screen, you can see that one example has been added. In order to test this out, you'll specify your input at the bottom left-hand side of the screen. That's where I'm going to write my review. Here is a review for a margarita pizza. I'm going to go ahead and send this prompt to the model, and the model response appears on the bottom right, and you can see it says sentiment positive. It comes back with only the sentiment because that's what we had specified in the example. I'll now specify another review for some chicken Alfredo. Clearly, this is not a very positive review, and you can see the model comes back with sentiment negative. Let's try yet another review. This one is a pretty neutral review but lacks standout flavor, so good for a quick bite. You can see the sentiment is neutral. There were a number of settings in freeform mode that we hadn't explored. Well, I purposely skipped over those because those same settings are available in chat mode in Vertex AI Studio, and chat mode is what we're going to look at next. In the freeform mode, we sent one-off prompts to the model and got responses. Chat mode is more for chatbot tasks, meaning you can set up a conversation with the model and have responses that go back and forth. The entire history of your conversation will serve as a context for the model, and the model will use that context when responding to your queries. Let's click through and get to this interface. You can see that the user interface is very similar to what we had when we used freeform mode, but it's not exactly the same. This user interface does not have the ability to add examples, to add variables, or insert media, but off to the right, you can see the various parameters that you can use to tune the response of the model. They are the same between freeform mode and chat mode. There are various models that Google offers that support chat mode. So if you click on this drop down here, you'll see all of the models that can be used in chat mode, starting with the latest Gemini 2.0. If you scroll down, you'll see the range of Google models, the third-party models supported, and the Palm 2 model that allows multi-turn conversations, that is, conversations in the form of chat. We'll stick with the latest model available at the time of this recording. That's the Gemini 2.0 Flash Experimental model. Flash in the model name refers to flash attention, a new technique for accelerating the attention mechanism in large language models. Attention is a core component of LLMs that allows them to focus on the most relevant parts of the input text while generating output. All modern generative models use an attention mechanism. However, traditional attention mechanisms can be computationally expensive. Flash attention is designed to be much faster and more memory efficient. This allows LLMs to handle larger amounts of data and generate responses more quickly. The chat mode offers system instructions as well. I'm going to specify a fairly large bit of context to this model, and I'm going to ask this model questions based on this context. This is an imaginary company, Luminate Goods, and I have a company profile here. There is some history of the company, some basic financials of the company from the year 2019 and 2023, and some future goals that the company wishes to accomplish. Now, let's set up a prompt. What types of products does Luminate Goods offer? I'm essentially asking questions where the answers may be found in the system instructions. And the model has correctly identified that Luminate Goods offers eco-friendly home products such as bamboo furniture, organic personal care, and some others. Let me ask a follow-up question. Are they involved in any community initiatives? Notice that this is like natural conversation. Here I use the word they without explicitly referring to Luminate Goods. But in the historical context of this conversation, I did mention Luminate Goods, so the model knows which company I refer to and it gives me a reasonable response. It correctly identifies that there are no specific community initiatives in the context, but based on what we've specified in the company profile, it makes some reasonable assumptions about the company. With all this prior context, here is a follow-up question from me. When were they founded and what were their revenues in the latest year? And here you can see I got the right response. They were founded in 2012, they rebranded in 2014, and in the latest year, 2023, their revenues were 45 million. Now, in the next example, we'll specify the system instructions for a chatbot that you might want to integrate into your product. Let's say your organization is a company that provides boot camps for people who are aspiring to be software engineers and data scientists. And then you have a chatbot that answers the students' questions about what boot camp they should enroll in. You might have a number of bootcamp offerings going on at any point in time, and that's what I've used to configure the system instructions for this chatbot. You're a chatbot for the county's software development bootcamp. Notice my first guideline, do not hallucinate. That's because these large language models are prone to hallucinating or making stuff up if they don't know the precise answer. This instruction will help the model stick to what it knows. I have a bunch of other instructions talking about the tone that the model should use. It should be encouraging and so on. And then you can see the various steps that the bot has to follow. First, decide the programming focus the student likes from two choices, web development or data science. Step 2 gives the various bootcamp options for web development. Step 3 gives the bootcamp options for data science. And steps 4, 5, and 6 specifies the exact bootcamp for Python programming, data visualization, and machine learning. Now, with these instructions, let's have a conversation with this chatbot. Hi, I'm a student looking to enroll in the bootcamp. What programs do you offer? Observe that it correctly gives me the choices between web development and data science. These are the two paths I could take. Correctly asks me to choose between these two paths. Let me say, okay, I think I'd like to study data science. I'm going to send this message and observe it tells me the paths that I can follow in data science, Python programming, data visualization, or machine learning. Let me go on conversing with the chatbot. Let me say, well, machine learning sounds cool. Let's see what the chatbot has to recommend. And it correctly recommends Introduction to Machine Learning with Scikit-learn as a course. But now I'm curious about what's available in web development. So I ask a follow-up question. And it correctly tells me that we have HTML and CSS essentials, JavaScript basics, and advanced front-end development with React. Based on the instructions, if you've already studied HTML and CSS essentials, the bot is supposed to follow up with another course that's JavaScript basics, and it indeed does. Notice here in this user interface at the top left, you can see that this prompt is currently untitled. Each time you open up this user interface, you're actually working within a prompt file, and you can actually name and save this prompt file if it's a prompt that you might find useful. Let's say you're trying out a few different prompts. In order to tune what gets you the best response, you can add additional notes to your prompt as well. So click on the three dots, go to notes, and here you can see I've added some notes saying, that the prompt that I have here is a chatbot for a coding bootcamp. I'm going to hit confirm and these notes have been added to my prompt. Click on the save button and you can name your prompt with something meaningful. Bootcamp course recommendation bot. And here, if you have the auto save prompts checkbox checked, every prompt you write will be auto saved to Google Cloud. I'm going to uncheck this because I don't want to auto save prompts, and I'm going to go ahead and save just this particular prompt. Once you've saved your prompt, you can always access it by heading over to prompt management on the left sidebar. Under prompt management, you'll find a list of all of your saved prompts, and we have exactly one at this point in time. You can see that it uses the chat mode. There is no media file associated with this, and you can see the notes that we've added to our prompt as well. And if you click through to the prompt, you'll go back to the UI we were in before. And on the top left, you can see the name of the prompt, Bootcamp Course Recommendation Bot. If you want to start a brand new conversation and you don't want any previous history, you can click on the three dots and choose Clear Conversation. Your entire chat history will be cleared. And you can get rid of the system instructions by clicking on this trash icon next to system instructions. We can now start afresh in our next demo. In this demo, we'll explore a few parameters that can be used to tune the response from the model, starting with the output token limit. Now, I've spoken of this early on, but I hadn't really explained it in detail. Now, we'll actually configure this parameter and see how the response changes. What exactly is this token limit? If you hover over the help here, you can see that the output token limit determines the maximum amount of text output from one prompt. That is, this controls the length of the model's response to your prompt. All large language models measure the length of the response in tokens. A token is not exactly equal to a word. A token is typically 3/4 of a word or approximately 4 characters. Generative AI models respond to your prompts by predicting the sequence of text or words that appear in the response. When you configure the output token limit, you can configure the length of the model's response. You can see that for the Gemini 2.0 model, this is set to 8192 by default. Let me reduce this so that the output token limit is just 200 tokens. By the way, understanding this token limit and the tokens used for the prompt and the response is important because this is what you're built for when you use these large language models. Notice my prompt here. My team is planning to work on a data science project. What libraries and tools can be used for visualization? Observe right below that, you see the little note 23 tokens. My input prompt comprises of 23 tokens. And when I send this particular message, you'll see that the message that I receive is truncated because I've specified that I just want 200 tokens in my response. You can see the message there. The response was truncated because the token limit was reached. If you look here at the bottom, you can see the response was 250 tokens. That's close enough to 200, and that's when it was truncated. So let's say I do want a longer response. Let me clear this conversation and let's try this once again. And this time around, I'm going to change the output token limit to something larger. I've set it to roughly 990 tokens. So a longer response, but not too long. I ask the same prompt once again, and notice this time around I get a longer response along with citations. If you scroll to the very bottom, you can see that Gemini returns citations from the original source that it used to provide you with this response. If you look at the bottom, you can see that the response had about 1034 tokens, and from the message, you can see that this response too was truncated, even though it was much longer than the previous ones. The Gemini 2.0 model gives long and detailed responses, and clearly the default token limit of 8192 is what seems to be best for this model. So I set the token limit back to 8192. I'm going to resend the same prompt to the model, and this time around the response will not be truncated. You can see the response is complete and has about 1959 tokens in the response. The next parameter that we'll work with to tune and control the model's response is temperature. But first, I'm going to set up some system instructions. Here I've asked the model to respond as a sports coach all ready to whip slacking athletes into shape. I've asked the model to play the role of a strict and unyielding sports coach. The response from a generative AI model is basically a sequence of predicted words or tokens from the model. The temperature parameter can be used to control how these tokens are picked. The temperature parameter can thus be used to control how deterministic or creative the model responses are. A higher value of temperature, that is, a temperature of 1 or above, produces more creative and diverse responses from the model, while a lower value of temperature, say close to 0, makes the output more focused and deterministic. Higher values of temperature result in less likely or low probability words being picked. Lower values of temperature result in high probability words being picked. The default temperature is 1, which offers a good balance of creativity and determinism. I'm going to lower the temperature to be basically 0, so the model will be at its most deterministic. And then here is my prompt. I'm feeling down and demotivated even though I have an important tennis match tomorrow. And here is my model responding as a motivational coach, strict and unyielding. You think champions have time for that garbage? And then you can see all of this angry stuff ending on a note of encouragement. Let's see what the model will do when it's more creative. Let's set the temperature to 1 and send the same prompt. I'm going to clear the original conversation and resend the same prompt. I'm feeling down and demotivated, even though I have an important tennis match tomorrow. And here you can see the model is much more creative and detailed. You can see a lot more of the text is in caps lock, and then the model says something about this isn't a tea party, this is war. Clearly more creative than what we saw earlier. And then you can see all of the detailed instructions for channeling the negativity that I feel. Now, what if we up the temperature all the way to 2? This will be the model at its most creative. The output should be the most random and diverse. I'm going to send the same prompt as before, and let's see what the model has to say. They're going to be out there clawing for every point, and you're over here moping. Clearly more creative, more vivid. Tomorrow's not a therapy session, it's a battle. The differences are pretty subtle, but you can see that this response is more creative, more diverse, and more vivid than the previous responses. Let me clear out the chat history and the system instructions here, and I'm going to set the temperature back to the more balanced one. With that done, let's see how we can use grounding for our model's response. Grounding refers to anchoring our model's responses or outputs to a specific context, knowledge source, or real world data to ensure that the model does not hallucinate and produces accurate and relevant responses. Grounding connects the model's reasoning to external inputs, factual databases, or predefined guidelines, allowing it to generate contextually appropriate and reliable responses. Grounding is turned off by default, as you can see here. Now, with grounding off, I'm going to send a prompt to the model to get a response. Can you please tell me how I can deploy a Django application to Google Cloud Run? Now, this gives me a pretty good response, and the Gemini model always gives me citation sources at the end. So you can see the actual response here, and at the very bottom, you'll find citation sources. You can always look through these sources to ensure that your model's response is accurate. Grounding goes one step further. So what I'm going to do is turn on grounding for this model, and you can see that the source for grounding is Google search. The Gemini model will now ground its responses based on a Google search that it performs for our query. You can also use the customize option to ground your results to some external database or files that you have in a cloud storage bucket. But here, let's just see how Google search works. Now click on more actions and let's clear the current conversation, and let's ask the model the same question again. Can you please tell me how I can deploy a Django application to Google Cloud Run? This time around, it gives me a list of steps and it gives me what link the step comes from. Observe that it gives me a reference link for every bit of instruction that it has generated, and I can click through to this reference link and verify that the source seems legitimate. Let's say you're actually following these instructions in order to deploy your app. Well, if at any point you get stuck, you can look at the original source and see whether the instructions have been interpreted correctly by Gemini. And here at the very bottom, you get Google search suggestions for your prompt as well. Super useful when you want to ensure that your model is not hallucinating. Some queries may require grounding. I'm going to turn grounding off once again, and I'm going to ask Gemini about the latest results of NVIDIA. Now, without grounding, you can see that this model only knows about results in late May 2024. I've recorded this in December 2024, so you can see that late May 2024 is quite old. It's over 6 months old, but I'm looking for the latest results. Well, this is not possible without grounding. So I'm going to ask the model the same query once again, but this time I'm going to turn on grounding. I'm going to ground my responses using Google search. So can you tell me what NVIDIA's latest results were like? And observe here the difference. I've now got the results for third quarter fiscal year 2025 ending October 27th, 2024. These are the most recent results at the time of my recording, and in your case, it's likely to be even more recent. And you can click through to the individual links and view where this comes from. You can see that these results are pulled right from NVIDIA's site. If you want your model to return responses based on some data that's stored in an external database, or your model's response has to be based on up-to-date current events, definitely use grounding for your model. You can ground with Google search results or with an external database. And you will see later on in this learning path how you can ground with your own external source when we work with the Python SDK for Vertex AI. Before we move on to the next demo, let me go ahead and turn off grounding, and we'll look at some other configuration options to tweak the model's response. In this video, we'll see how you can control a model's response using stop sequences. Stop sequences are predefined strings or tokens that instruct a language model to halt further text generation when encountered. They are used to control and limit the model's output by specifying certain words or characters that, once generated, signal the model to stop producing additional content. You can see that stop sequences stops response generation if the model encounters this particular stop sequence. And you can add up to 5 stop sequences for a model. To start off, I'm not going to specify any stop sequence. And here is my prompt. Can you give me some potential names for a real estate company in the form of a numbered list? Just names, please. You can hit Control Enter or Command Enter to send this message, and observe that it's given me a very long list. There are a total of 20 items here in this list. Let's say I wanted to stop generating names after I've seen 10 names. I can add a stop sequence, and I've done so, and the stop sequence says 11. This means that the model will stop generation as soon as it sees the text 11. Well, let's try this out. I'm going to go ahead and clear the current conversation and send the same prompt to the model. Give me some potential names for a real estate company in the form of a numbered list. And observe that I just get 10 names. As soon as it typed out the number 11, well, the stop sequence was encountered and the model stopped generation. Now, some of these names contain estate or estates. I'm going to add those words as stop sequences as well. So I've added estates as a stop sequence, and I'm now going to add estate as a stop sequence. The moment the model produces a name with estate or estates, the model should stop generating. I've sent the same prompt once again, and observe that it was about to say submit estate or submit estates. Basically, it just stopped generating, and the word estate, our stop sequence, isn't present in the response. Now that we've understood stop sequences, let's see how we can configure the output format of the model. I've cleared up all the stop sequences, and I'm going to clear the conversation as well. Now, by default, the model produces output in the form of plain text. This is why whatever prompt we send the model, we get the response in the form of natural language plain text. However, you can configure the model to give you a response in the JSON format. In fact, if you need a strict JSON response, you can configure the schema for the JSON format in which the model should produce a response. That's exactly what we're going to do next. Click on the output format dropdown, and let's switch over to the JSON format. This is very useful if you have a lot of information in the form of plain text and you wish to convert that to a more structured format so that it can be analyzed in your database or using a machine learning model. Here, I'll just use this for data generation. I've set the output format to be JSON, but I haven't explicitly specified a schema in which I want the results. Let me go ahead and submit a prompt to the model. I want the model to generate fictitious student data for 10 students. Notice the JSON response. Every student seems to have a student ID, name, major, GPA, and credits. The model picked fields at random for the JSON response. Maybe I want the fields in a specific JSON structure. Click on Edit, and here you can specify the JSON schema that you want the model response to follow. Here is the JSON schema. You can see type array, which means the result should be in the form of an array or a list. And the items in the list are all JSON entities. They have the type object. The properties field tell you the properties that we want for each entity. For each entity, we want a student name where the value is of type string. We want age where value is of type integer with a minimum value of 0. We want major where the value is of type string. We'd like the GPA, which is of type number with a minimum of 0 and a maximum of 4. And we'd like the university that is of type string. And the required properties for every entity in the list are student name, age, major, GPA, and university. This is the standard JSON schema specification that you see here. Well, let's go ahead and apply this schema, and let's ask the model the same question again. Please generate fictitious student data for 10 students. And notice this time around, the JSON schema that we had specified has been followed for these students. Let's look at the last student here, age 20, GPA 3.3, major sociology, student name Julia Martinez, University Social Studies Institute. Now, the safety filter settings that you see here are hard to demonstrate because the model has been trained to not generate unsafe responses. You can configure the safety filters along 4 parameters: hate speech, dangerous content, sexually explicit content, and harassment content. You can see that the safety filters are all set to off by default, but you can set up a more strict configuration: block few, block some, block most. These options are available for all of these safety filters. Even with the safety settings off, I try to generate unsafe content, and the Gemini model refused to do so. So these models are trained to generate safe content, and it'll take a lot more than my playing around to jailbreak these models into generating unsafe content. But you should know that you can adjust the likelihood of receiving a model response that could contain harmful content and tweak that using these safety filters. In this demo, we'll work with the Imagine model that Google offers for image generation, and you'll see how we can generate very photorealistic images. I must say that this image generation model of Google's quite surpasses the other image generation models that I've played around with. In this demo, we'll work with the image generation API using the Vertex AI Studio. Later on, we'll see how we can generate images using the Python SDK. Click on Generate Images, and this will take us to the Vision interface. Observe on the left, we have the overview, the freeform, and chat. We've already played around with those, and now we are working with Vision. Now let's take a look at the models that are available for generating images. The default model that's selected is the Imagine 3 model. If you click on this drop down, you'll see that there is another variant of this model, Imagine 3 Fast, for fast generation. The Imagine model is very powerful, and it supports a variety of use cases: generating novel images using a text prompt, generating new backgrounds for product images, editing or expanding an uploaded or generated image using a mask area that we define, editing an entire image or just a part of an image with a text prompt, upscaling existing generated or edited images, and so on. Just a little bit of this functionality is exposed here in the Vertex AI Studio. So what we have here is a limited preview of what Imagine has to offer. Let's select the Imagine 3 model, the default model, and you can configure the number of images you want generated. Let's set that to 1. I just want 1 image for every prompt. I love dogs and I love generating dog images, so I'm going to ask generate an image of 3 dogs dancing happily. Let's send this to the model and wait for a few seconds, and here is the response from the model. You can see 3 cute dogs dancing quite vigorously. Observe how real the image looks. You can have the model generate multiple images. In fact, it can generate a maximum of 4 images. For the same prompt, if you have 4 images, you can then pick the one that you like best. Here is my new prompt: a steampunk airship floating above a Victorian era city at sunrise with golden rays reflecting on the metal. So I have some photo effects as well that I want in this image. Let's take a look at the images that it has produced, and here are the 4 generated images. What you see here are the image thumbnails. You can select a particular image and zoom in and get a better view. You can see the image is pretty realistic. Look at those clouds and the smoke. Let's now generate images using the other model, the Imagen 3 Fast model. The original Imagen 3 that we used is Google's flagship model, which prioritized the highest possible image quality and detail. And that's exactly what we got in the images that were generated so far. The Imagen 3 Fast model is optimized for speed, and it generates images much faster than the standard Imagen 3. It will produce high quality images but may not have the same level of detail or realism as the Imagen 3 model. I'll update the prompt here for the Imagen 3 model: an ancient library lit by candlelight with shelves reaching the ceiling and a magical glowing book on a table. I'll still get 4 image results in the response, and you'll see that the images are generated much faster. Let's select a particular image and take a look, and the image you can see is pretty good, but maybe it has a little less detail and texture than the original Imagen 3 model. The fast model is still pretty good though. It's hard to really tell the difference in the generated output. Now you can change the aspect ratio of the images generated. By default, the aspect ratio is 1:1. Aspect ratio is the ratio of the width of the image to the height of the image. The height and width of images are equal to one another. Aspect ratio of 9:16 will give us an image in the portrait format, kind of like an image taken by a vertically held mobile phone. Now with this, let me change the prompt. I want a giant teacup floating on a calm sea under a starry sky, and I want an aerial shot from above. Here I've specified the angle of the camera as well, and while you can see the giant teacup in the 9:16 aspect ratio, it's not really an aerial shot from above. This model hasn't really followed that part of my instruction. Otherwise, the images generated are quite vivid and realistic. Let's try generating an image with a different aspect ratio. Let's try 16:9. This is in landscape mode. Here I want an old pirate ship in a stormy sea rendered in a vintage sepia tone. And here are the 4 generated images, and I must admit they look quite beautiful. Maybe you're generating images to use in a product catalog or to use in a presentation. If you like an image, you can go ahead and download this image. Click on the download option, and this image will be saved with digital watermarks to your local machine. A digital watermark is like an invisible signature that's embedded within the image data itself, and it's used to identify the creator or owner of the image, and it can help protect against unauthorized use or distribution. I'll just go ahead and export and save this image to my local machine in the downloads folder. It'll just be called image.png. You can quickly verify that the image is indeed available in downloads. There is our image.png file, and there you can see the old world sail ship. If you'd like to export all of the images in one go, you can click on this export button here on top. This will download and export all of the images to your local machine and give you those images in a zip file. You can see the images.zip file here. This will contain all 4 images. Once it's downloaded, let's head over to the downloads folder. There is our zip file. I'm going to double click and unzip this, and within the images folder, you'll find the 4 images that were downloaded, the 4 images of the sail ship. Let's head back to Vertex AI Studio. If you'd like to clear the images that have been generated, you can click on the reset button here. This will clear your prompt and your images. Now, let's say you had generated a few images earlier, but you can't remember the prompt and you want to access those images. You can click on the history button. This will take you to a page which will show you all of the images that you've created so far and the prompts used to create those images. A quick way to go back to an image that you maybe liked or want to do something with. In this demo, we'll see how we can use Google's models for translation. And we'll do this via the Vertex AI Studio, which means we'll be able to play with the translation models without writing any code. Now you can see the option here in Vertex AI Studio that says translate text. That's the option I'm going to select. Google offers several models that enable text translation. If you look at this drop down, you can see that you can perform translation using Gemini 1.5 Pro models. These Gemini 1.5 models are general purpose LLMs and can be used for tasks other than translation. Now, the other two models that you see here, the translation LLM and the NMT model, these are specialized translation models. NMT here stands for Neural Machine Translation. When you use the translation LLM, you can tailor responses by providing example translations so that the responses more closely match your style, tone, and industry domain. The model will use your examples as few short context before translating your text. This is useful when you want to use a more formal tone or a more casual tone in your translations. Now, we won't really be using the examples here. We look at basic translation using the translation LLM. So let's go ahead and select that. Now, here at the bottom, you can specify your source and target language for translation. I should tell you that you might find that there are just a few languages listed here, but this translation LLM can translate other languages as well. It's able to detect and translate languages beyond what's listed here. However, these languages listed here will have the most reliable translations. So let's translate from the source language English and let's look at what target languages the translation LLM can translate to. There's Arabic, there's Chinese simplified, Hindi, Italian, Russian, Portuguese, and so on. Let's go with a very basic English to French translation. I'd like to translate the sentence, I'm very much in a hurry. How long before we get to our destination? Let's send this to the model, and here is the translation in French. I don't know any French at all. I verified this with a friend, and this translation is indeed correct. Let's translate to another language. Same source language English, but my destination language is going to be Italian. This is the same sentence as before. I'm very much in a hurry. How long before we get to our destination? And here is the same sentence in Italian. Again, because I don't know Italian, I had to rely on other models to verify that this translation was correct. I'm now going to translate from English to Hindi. Hindi is a language that I do know. Let me hit submit, and here is the translation. मैं बहुत जल्दी में हूँ, हम अपने गंतव्य तक पहुँचने में कितना समय लेंगे? This translation is spot on. It's not just the common languages that are translated well, rarer languages will work well too. Now let's change our source language. Instead of English, let's specify our input in say Korean. Here is a sentence in Korean. Let's see if it translates to the target English language correctly. Let's submit this. I like to drink coffee while watching the sunrise in the morning. This is a perfect translation. Now, if you click on the advanced option here, you'll find that all of the translations have been performed with the temperature of the model being set to 0. That is, the model is at its most deterministic and least creative and diverse. The highest value of temperature for the translation LLM is 1. So let's set the model parameter to be equal to 1 and see what this translation looks like. We'll do the same Korean to English translation for the same sentence. And here, notice how much more vivid the translation is. I love to have coffee and watch the sunrise in the morning. So earlier it was like, but now it's love. The sentence is phrased a little differently as well, even though it conveys the same meaning. It turns out the translation LLM does not rely on you specifying the correct source and target languages. Now, my input prompt is in Korean, but I'm going to basically tell the translation LLM that my input prompt is in French and I want the translation in English. Go ahead and hit submit. Notice that it still detects Korean correctly and gives you the correct translation. Now, just be aware that this may not always be the case. It's important that you specify the right source language so that your translation is accurate. I'm now going to update the source language to be a different one. I'm going to have my original text in Hindi. Here is the original text in Hindi and I want it translated to English. Let's submit this, and this translation is perfectly accurate. Now I'm going to translate from a source language that does not exist in the list. I'm just going to pick a language at random, say German, but my original text is in Tamil, which is a language from India which is not present in the drop-down list for the translation LLM. I was just curious to see whether the translation LLM could translate languages beyond the languages in its list, and yes, indeed, it can. Maybe these languages are still in development in experimental stage. That's why they're not present in the drop down. I'm going to try another source language here, another language spoken in a different part of India. This is Gujarati. And I'm basically going to indicate that the original is in English and I want this translated to Hindi. So I want to go from Gujarati to Hindi. Let me hit submit. And you can see that this translation goes through correctly as well. The translation LLM does indeed understand languages beyond what's specified in the list. Let's try another unusual language, Arabic, where you read from right to left. I want to translate from Arabic. Observe that for Arabic, you can only translate to English. None of the other languages are supported at this point in time. Let's go ahead and perform this translation, and you'll see that this goes through successfully as well. And this translation is perfect. In this demo, we'll see how we can use the speech-to-text and text-to-speech APIs that Google Cloud has to offer. And we'll work with these APIs via the Vertex AI Studio, which means we'll experiment with these APIs without writing any code. Click on Convert or Synthesize Speech from the overview page of the Vertex AI Studio. Observe on the left under Vertex AI Studio, we have speech selected. We'll first explore the text-to-speech functionality. Observe that Google offers us 3 different voices. Google has male and female voices for English and a male voice for Spanish. At this point in time, other voices are not supported via the Vertex AI Studio. Now I'm going to specify some text here in this text field and get the equivalent speech. So I'm going to convert this text to speech. If you look at the speed option, it has been set to a default of 1. This means that the spoken text will be at a normal pace, not too fast, not too slow. Also note that I have the English female voice selected. Let's go ahead and click on submit this text to the model and get the speech output. You can see that you can play the speech output here at the bottom. Let's click on the play button and see what this sounds like.
The 90s TV era gave us sitcoms like Friends, animations like Rugrats, teen dramas like 90,210, and sci-fi hits like The X-Files, a nostalgic mix of heart, humor, and innovation.
That sounded pretty good with the right intonation. Let's try out another sample. Let me just switch this over to English male. Again, we'll leave the speed as 1 and go ahead and hit submit and let's play this out.
The 90s TV era gave us sitcoms like Friends, animations like Rugrats, teen dramas like 90,210, and sci-fi hits like The X-Files, a nostalgic mix of heart, humor, and innovation.
Let's try the Spanish male voice. Now I have specified my text in English, but I'm choosing the Spanish male voice. Let's hit submit and see what the result looks like.
The 90s TV era gave us sitcoms like Friends, animations like Rugrats, teen dramas like 90,210, and sci-fi hits like The X-Files, a nostalgic mix of heart, humor, and innovation.
You can see that it's the same English text spoken with a very heavy Spanish accent. Let's just specify the same text in Spanish and choose the Spanish male voice. This is what I have for the Spanish text and I'm going to hit submit. Let's hear the result.
La era de la televisión de los 90 nos dio comedias como Friends, animaciones como Rugrats, dramas juveniles como 90,210 y éxitos de ciencia ficción como The X-Files, una mezcla nostálgica de co.
Granted, I'm not very familiar with Spanish. In fact, I don't know any Spanish at all, but I thought that sounded pretty good. All of the speech generated so far was at a normal speaking rate. You can hover over the question mark on speed and you can see that speed allows you to change the speaking rate by a factor of the speed value. So a value of 1 is the normal speaking rate. You can go up to 4 times as fast and you can go slower as well. Now I'm going to switch the voice over to being the English male voice. And let's change the text that we want to convert to speech. This is about the 90s music scene. I'll submit and let's hear the result.
The 90s music scene brought us grunge icons like Nirvana, pop stars like Britney Spears, hip-hop legends like Tupac, and boy bands like Backstreet Boys. A mix of angst, energy, and unforgettable hits.
That's what a normal speaking rate sounds like. Let me go to 0.55 on the speed. So the resulting text will be at about half the normal speaking rate.
The 90s music scene brought us grunge icons like Nirvana, pop stars like Britney Spears, hip-hop legends like Tupac, and boy bands like Backstreet Boys.
Well, I cut that off because I have to admit that was quite slow. Let's try with the faster speed. Let's go at 1.5 times the normal speed.
The 90s music scene brought us grunge icons like Nirvana, pop stars like Britney Spears, hip hop legends like Tupac, and boy bands like Backstreet Boys. A mix of angst, energy, and unforgettable hits.
That was super fast. That's gotten me talking faster as well. Let's up the speed to about 2.5 times the normal speaking rate.
The 90s music scene brought us grunge icons like Nirvana, pop stars like Britney Spears, hip hop legends like Tupac, and boy bands like Backstreet Boys, angst, energy, and unforgettable hits.
That was way too fast. I barely understood what the voice said. Let me reset settings so that we go back to the normal speaking rate. And let's now explore the speech to text API. Speech to text allows you to transcribe the spoken word. You can either upload an audio file from your computer or you can record your own voice and convert the spoken word to text. I'm going to use a number of different audio files to see how speech to text works with different accents and different languages. You can see on the right that speech to text is powered using a model called Chirp, and we are currently on Chirp version 2. Chirp allows multilingual automatic speech recognition or ASR, and it's a way better model compared to the first generation of Chirp models. Observe here you have a drop down that you can use to specify what language the original audio is in. It's set to English US by default, but you can see that it supports a variety of different languages, including languages that are spoken in only one part of the world. For example, Assamese is a language spoken in one state in India. If you select Auto Detect Language, it'll auto detect the original language and provide a transcription. Now, here you can explore the different languages available. Let's start with simple English United States and see whether it recognizes the audio and gives us the corresponding text. Let's browse for the audio file on our local machine. Here I have a WAV file for US English, and that's what I'm going to upload. I'll just play a small portion of this file, not everything because it's pretty long.
The 1990s were a golden age for TV, filled with unforgettable shows across all genres. Family sitcoms like Friends and Full House brought laughter and heart.
This is an AI generated voice speaking US English. Let's submit this and see whether the correct transcription is available. And you can see the transcription is indeed right. Now, English is spoken in many countries across the world, and each country has its own accent. I'm curious to see how this transcription is performed for different accents. I've selected English India here, and I'm going to upload a WAV file where English is spoken with an Indian accent. Let's first hear the audio, at least a bit of the audio.
The 90s music scene was a melting pot of genres that defined a generation. Grunge exploded with bands like Nirvana and Pearl Jam, bringing raw emotion and rebellion.
This is an AI generated female voice speaking English with an Indian accent. Let's see its transcription, and you can see that the transcription is perfect, even with the accent. Maybe the Indian accent wasn't a sufficiently challenging one for the model. Let's try an accent that is much thicker and much heavier. Now, this is English spoken in the Nigerian accent. That's the next audio file that I'm going to upload. Unfortunately, there is no Nigerian accent present in the dropdown. So I'm just going to go with the closest possible English as it's spoken in the United Kingdom. You might argue that Nigerian accented English isn't really English as it's spoken in the United Kingdom, but this was the closest I figured. I'm going to upload the Nigerian English.wav file and let me play out the contents of this file so you can see what this sounds like.
The 90s music scene was a melting pot of genres that defined a generation. Grunge exploded with bands like Nirvana and Pearl Jam, bringing raw emotion and rebellion. Pop dominated the charts with Britney Spears, Spice Girls.
Because I don't hear this accent in my day-to-day life, I have to admit I found this pretty hard to understand. Let's see how good the model is at transcribing this. And I think it's done a great job. The transcription is perfect. Now we've seen how speech to text works for different accented English. Let's see how it works with other languages. I've chosen the Danish language as the language for the audio input that I'm about to provide. Let's browse the files that I have locally and notice I have a Danish.wav file and that's the one I'm going to upload. Let me play a bit of this file so you can hear the talk in Danish.
Mode i 90'erne var en dristig blanding af grunge, glamour og afslappet elegance. Flannelskjorter, slidt af jeans og Doc Martens blev ikoniske takket være grungebevægelsen ledet af Nirvana.
That's the Danish text that we are about to transcribe. Let's go ahead and hit submit. And here you see the Danish transcription. Now, in order to verify that the transcription was correct, I'm going to copy this over and head over to the translation API. Unfortunately, in this dropdown, Danish is not available as a source language. So I'm just going to pick French as the source language by default, even though this text is in Danish. Let's translate to English, and you can see that this is what was transcribed. I know the transcription is correct because the way I got the Danish voice was I started off with this English text, translated the text to Danish, and then used the Danish text with a text to speech converter to have an AI generated Danish voice. And that's what I fed into the Vertex AI Studio speech to text API. So far, our speech to text is working pretty well. Let's head back to speech and let's head over to speech to text to try some more transcriptions. The next language that I'll try is going to be an Indian language, Bengali, as it's spoken in India. Let's browse for the audio file. There is a bengali.wav file that should be available along with the assets of this course. Go ahead and select this and upload this. Let's hear the contents of this file first.
আধুনিক কৃত্রিম বুদ্ধিমত্তা কণ্ঠস্বর সহ পাঠ্যকে বক্তৃতায় রূপান্তর করুন কাজ ভিডিও সম্পাদনা ব্যবসা বিজ্ঞাপন সামাজিক নেটওয়ার্কিং
That was just a short snippet of the original audio. Let's go ahead and hit submit, and here is the Bengali transcription. Notice that you get the text in the same language as the input audio. Let's head over to translation, our good old friend, paste in the Bengali text. Well, Bengali isn't an option for the source language, so I'm going to say it's Hindi, and I'm going to ask it to translate this to English, and this is what the original text was. So the transcription by the speech to text API was perfect. Generative AI models are evolving very rapidly. Something that was not possible yesterday may be mundane and just par for course today. If you'd like to explore what these models are capable of at the time you're actually working with these models, a great resource is the Prompt Gallery. The Prompt Gallery on Google Cloud showcases a wide range of prompts for different use cases, and you can explore these prompts, see how they are configured and set up. This will allow you to understand the capabilities of the model, how it can work with documents, images, text, video, etc. The prompt gallery will also give you ideas on how you can integrate all of this functionality into your product using Vertex AI. You can see that the prompt gallery has a large number of built-in prompts. You can search for sample prompts, or you can specify the task that you're interested in and search for examples for those tasks. You can specify features or prompt types. Let's take a look at the tasks first. Observe that there are example prompts to get you started with all these tasks, answering questions, code, summarization, transformation, and so on. Gemini models are multimodal, meaning they don't just work with text, but they work with video, audio, documents. You can look for prompts with all of these different features. You can dive into sample prompts that make use of YouTube videos, has examples, has system instructions, or have multimodal inputs. And if you look at prompt types, you can look at chat prompts and free-form prompts. Based on your use case, you might have to make use of audio, documents, image, text, or video. You can use those buttons that you see on top to filter prompt examples based on your use case. I have no filters applied, so listed on this page include all of the prompt examples from the prompt gallery. Let's drill down into a few of these just so that we get familiar with the prompt gallery. Let's say you want to work with documents. I'm going to select the document button, and now the prompt gallery shows me examples that make use of documents as a media input to the Gemini model. We haven't really worked much with documents so far, so let's try out this prompt example, document question answering. This allows you to upload a document to the model and ask questions of the model. The model will then look for the answers in the document that you have provided. Let's first look at the example that they have, then we'll upload our own document. There is a certificate of incorporation that has been uploaded, so I'm going to open up this document and show you its contents. So here you can see it's a fairly complex document This is the kind of document that you might receive from a government authority that certifies your business. It talks about a penalty if you fail to file your annual report. Most importantly, observe that in the second paragraph, the certificate of incorporation will be revoked after 60 days from the date of this notice if we fail to file the annual report. So this is a simple document, but the language there is pretty complex. Notice the example prompt. What is the exact date that the certificate of incorporation or authority will be revoked? Explain your logic. Let's submit this and observe how well the model breaks this down. The date of the letter is June 19, 2023. There are 60 days to file the annual report. It's very methodical in calculating its logic. It starts with the start date, adds 60 days, and gives us the final answer. The certificate of incorporation will be revoked on August 18th, 2023. I must say, I was pretty impressed with the model's reasoning ability. Now, let's try with a simpler document that I have on my local machine. This is a manual that I created for the Electro Gizmo X3000. And it talks about how you'll actually use this product, how you power on and off, its usage modes, and so on. A fairly simple manual. I've cleared out the existing prompt. Let's insert this as a document and ask questions about this document. So select this document from your local machine and upload it to the model. Here's my prompt. How do I know that it is fully charged? The Electro Gizmo, how do I know when it's fully charged? Let's send this to the model, and here is its response. According to the user manual, the indicator light will turn green when the device is fully charged. Here is another question that I had. How do I customize settings in this gizmo? Let's see what the model has to say. Well, you can customize settings by long pressing the mode button for 5 seconds. And this is correct. You can verify this against the original document. Let's go back to the prompt gallery and explore some more use cases. We made changes to this prompt. I don't really want to save those changes, so hit continue. Observe that back in the prompt gallery, we still have the document button selected. So those are the use cases that we find here. Let's choose another use case. Let's go with the writing assistant. You can use these generative AI models to allow you to summarize long documents concisely and succinctly. Let's not go with what they have. I'm going to upload another document. You can try out the existing prompt if you want to. I'm going to insert media, and on my local machine, I have an old presentation for Apache Spark. This is a presentation that I downloaded from the Databricks GitHub repository, and it's quite an old presentation, but it's fairly detailed and contains many pages and visuals. I've uploaded the document, and here's my prompt. Help me transform this document to an engaging presentation on Apache Spark. The presentation should have only 4 slides. At this point in time, the Gemini model doesn't actually produce slides, but it'll give you detailed information of what should be in each slide, what should be the title, and what should be the bullet points for each slide. And it'll also suggest diagrams from the original document that you can include in each of these slides. Now, I would recommend that at this point, you should double check the presentation with the original source to make sure the important points have been captured. What I've found here is that these models on the whole do a pretty good job. Back to the prompt gallery, let's look at some other use cases. So we are done with documents, so I'm going to deselect that button and let's go with, say, text use cases. We've already explored a whole number of text use cases. I'm looking for something different. Somewhere in the middle of the page, you'll find one for company financial analysis. Let's pick that. Here's what's interesting is the system instructions that have been provided to the model. You can see that the system instructions are very detailed. I really like how these system instructions are set up. Observe there are different sections. We first have the rules that the model has to follow. It should not hallucinate. It should not use the internet. It should write only in English, and it should only use the information provided. Note that the bot is only allowed to answer questions about financial analysis. Otherwise, it will say, I'm sorry, I only help with financial analysis. We then have the instructions for the bot. Number 1 is if the user asks an income statement analysis. The next section talks about if the user requests a cash flow analysis. That's number 2, and there are many subsections there. And number 3 is if the user requests an efficiency analysis. Now, the actual financial statement has been provided within the system instructions, but you may want to provide the financial statement in a PDF document that you upload to the model. We have the statement of operations, statements of cash flows, and the balance sheet of the company. All right, with the system instructions defined, let's ask a question. Please explain the cash flow of the company. And the model gives me a very good response. It breaks down the cash flow by year, it discusses it, it talks about the investing cash flow, the financing cash flow, and all of the details that are available in our system instructions. Let's ask the model a different question about the company. How profitable is it? Let's see what the model has to say. It realizes that it has to perform an income statement analysis and it computes the gross profit margin, the operating profit margin, and then finally it gives you the net profit margin. And what I really enjoyed here were the final recommendations, where it discusses the company's profitability and tries to deduce reasons for its decrease in net profit margin in 2022. Let me ask a question that's closely related to financial analysis. Do you think this company is worth investing in? Well, let's see what the model has to say. And it apologizes. It only helps with financial analysis. It doesn't talk about investments. Let's go back to the prompt gallery and talk about a different kind of prompt. We'll work with a coding prompt. We haven't done very many coding examples yet. Now, somewhere in the middle of the screen, you'll find a prompt for describe Python code. This allows you to paste in Python code in the prompt and get an explanation from the model. The system instructions are simple. The model behaves as a technical writer. I'm going to get rid of the existing code and supply my own Python code. Notice the prompt, generate detailed documentation with a one-paragraph summary of the overall purpose of the code at the beginning and a thorough explanation of each function. The Python code that I've pasted in, you can read this through at your leisure, is essentially a simple task management system. So we have a task, we have a task manager, and then we have the main function that uses this task management system. Let's see what the model has to say about this code. And you can see that the model explains this perfectly. It implements a simple task management system. It allows users to add tasks with titles. It then explains each class, each function within the class, and the main function. If you're working in a new code base and most of the code base is unfamiliar to you, you can definitely use this prompt to help you understand what's going on. Let's go ahead and try one last example here in the prompt gallery. So far, we worked with text and documents. Let's now work with images. We'll work with audio and video when we use the Python APIs directly. Let's look at some image examples, and I'm going to choose fill an empty form. Here I thought the pre-built example was quite amazing, so we'll just go with that. Notice that there are two documents. There is a source document from which we'll get the information needed to fill out the fields in the target form. And then we have the target form as well. Let's first look at the original document. So I'm going to click on this. This seems to be a short resume for a fictitious individual, Alice Doe. Now, this is the source document. Let's take a look at the target form, which we have to fill in. And you can see it's a form that asks for a bunch of personal details. Unfortunately, it's hard to get a clear view of this form. The red box that you see outlined are the education details. That's what we want to extract from the resume and fill in this form. Notice the prompt below. Our question to the model is, what is the field name in the red box? What value should I fill in the red box? And output this fill value in the last line. Let's submit this, and you can see it tells you fill in Master of Business Administration or MBA, because that is Alice Doe's qualification.